Hello, my fellow animal lovers. How are you today? Before I ferry you to dreamland, if you love the content and you love animals, I encourage you to show your support by subscribing. By the way, tell us where you are in the world in the comments section. What time do you like watching our channel? I look forward to reading all your comments. Enjoy. Chapter 1. The world of the lizard is a realm of profound quiet, governed not by the frantic tick of a clock, but by the deep, patient rhythms of the natural world. A biological rhythm, as it is understood, is a self sustaining system, one that responds with grace to the cues of its environment rather than attempting to impose its own rigid schedule. The lizard embodies this philosophy entirely. As an ectotherm, it does not possess the ability to generate its own warmth internally, instead relying on external sources, like the sun and heated surfaces, to regulate its body temperature. This dependence means its very existence is a passive, gentle negotiation with the sun and the earth. Lizards engage in what is known as behavioral thermoregulation, a crucial process for their survival and physiological functioning. When a lizard rests on a cool stone in the morning, it waits without urgency as the sun's rays transform the rock from a surface of coolness into a cradle of warmth. This basking behavior is a deliberate strategy to absorb heat, allowing the creature to reach its preferred body temperature range. Reptiles have specific optimal body temperatures, which are essential for their metabolic rate, activity levels, and overall survival. If their body temperature falls outside this range, they can become sluggish, inactive, or even ill. The lizard's body temperature is a direct and quiet reflection of its surroundings. When too cool, a reptile will actively seek out patches of sunlight to warm up or find a sun warmed rock. When too hot, it will retreat into shade, water, or burrows to cool down. This shuttling between different thermal environments is a primary method of maintaining a stable internal temperature. Some lizards can even adjust their body posture to maximize or minimize heat absorption, and some can alter their skin color to reflect or absorb heat more efficiently. This constant, deliberate management of body temperature highlights that while their existence appears passive, it involves sophisticated behavioral strategies. There is no struggle, no rush, only a serene surrender to the inevitable transition of light and heat, embodying a deep state of passive acceptance, a model of how to shed internal tension and simply exist in the present moment, held by the unhurried hand of the earth. Ectothermy has significant implications for lizards, allowing them to conserve energy compared to endothermic animals like mammals and birds, which generate heat internally. Their metabolic rate can vary greatly with ambient temperature. When temperatures are cooler, their metabolic rate decreases, and when warmer, it increases. This allows them to survive on far less food than mammals. However, this energy conservation also makes them vulnerable to environmental temperature fluctuations, underscoring the vital importance of effective thermoregulation. Research has shown that lizards are often working hard to achieve preferred body temperatures, and that their survival is directly linked to their ability to effectively manage their thermal environment. This intricate dance with the sun and stone is not merely survival, but a profound connection to the elemental forces that shape their world. Ectotherms in low temperature environments often display higher metabolic rates at lower temperatures than those in warmer environments, an adaptation that helps offset the challenges of activity in cool conditions. This physiological adjustment allows for greater flexibility in activity patterns, helping to ensure that optimal metabolic function is maintained when the environment is not ideally warm. However, it's essential to remember that while the lizard's body temperature can reflect its surroundings, it's not merely a passive acceptance of whatever temperature is available. Through behavioral thermoregulation, lizards exploit their thermal resources to maintain body temperatures within a narrow range, critical for their physiological and ecological processes. Chapter 2: Sensory World of the Lizard. This enigmatic creature of quiet light experiences its world through an exquisitely rich and intricately woven tapestry of sensory information, where each subtle detail registers as a gentle whisper within a magnificent, overarching silent symphony. Lizards, particularly those species that have adapted to inhabit arid regions, perceive their environment not as a desolate or empty expanse, but rather as a realm of crisp, free field soundscapes wherein profound quietness prevails and dominates the acoustic landscape. Within this prevailing quiet, one can discern the subtle and intricate hum of life itself, the delicate scattering of sand under a gentle breeze, the distant ephemeral rustle of dry grass swaying, and the faint yet reassuring chorus of geckos clicking as the sun gracefully begins its descent towards the horizon. Even the occasional calls of ravens circling high above, or the rapid, almost imperceptible fluttering of hummingbird wings, are meticulously woven into this larger, calmly composed natural soundscape. This entire sensory experience of sound is profoundly likened to a haiku poem, a form where each precisely placed note or sound conveys the maximum possible information with the minimal expenditure of energy, thereby speaking volumes about a profound sense of efficiency and an expansive spaciousness in their auditory perception. It is a world where even the most seemingly harsh or abrasive sounds, such as the relentless blowing of a strong wind across rugged rocky terrain, can be perceived as an integral and harmonious part of a larger natural and rhythmic flow. Lizards are endowed with a diverse array of specialized sensory organs, each meticulously adapted to the specific demands and nuances of their particular habitats. Their sense of hearing, while often not possessing the same level of acute sensitivity as that found in many mammals, is typically exceptionally well suited to precisely detect subtle vibrations in the ground and to perceive low frequency sounds. These sounds are often crucial indicators of the presence of potential prey moving stealthily or approaching predators. Most lizard species exhibit commendable auditory sensitivity spanning a significant range, typically from approximately 100 to 4,000 hertz. This range encompasses a substantial portion of the human auditory spectrum, although it remains somewhat more restricted than the broader hearing capabilities of the majority of mammals. Certain species, such as the highly specialized geckos, possess particularly sensitive hearing, distinguished by extensive differentiation along their basilar membranes, which allows for finer discrimination of sounds. Anatomically, they are equipped with functional eardrums, tympanic membranes, intricate eustachian tubes, and a stapes, which is a tiny stirrup-shaped bone that plays a critical role in efficiently conducting sound vibrations from the eardrum to the delicate inner ear. For many burrowing lizard species, airborne sounds hold less significance than the crucial low frequency sounds that are transmitted directly through the ground, which they are expertly capable of perceiving via bone conduction. The distant chorus of geckos clicking, a characteristic nocturnal sound heard throughout many arid regions, very likely plays a pivotal role in their complex social interactions or serves as a clear signal for territorial claims among individuals. The varied physical textures inherent in these diverse habitats introduce yet another intricate layer to this already tranquil and rich sensory world of the lizard. The distinct feel of sand, often dry, loose, and granular, is sharply contrasted with the smooth coolness of a stone that has been thoroughly warmed by the sun's embrace. Lizards possess highly specialized touch receptors, which are scientifically referred to as mechanoreceptors or sensilla, distributed extensively across their entire body, with particular concentrations found on their feet and tail. These highly sensitive sensilla empower them to discern even the most subtle differences in substrate texture, which is absolutely critical for effectively stabilizing their body while skillfully navigating challenging terrains. This tactile feedback is also instrumental in facilitating proper posture and, crucially, in detecting substrate borne vibrations, which can be intimately associated with locomotion, the detection of both predators and prey, and potentially even communication within their species. A lizard inhabiting a tropical setting, for instance, might distinctly feel the slipperiness of wet leaves after a rain and the damp, cool earth beneath a dense, overarching canopy where the light is exquisitely filtered and softly diffused. The density and precise morphology of these cutaneous mechanoreceptors can exhibit significant variation across different lizard groups, often reflecting specific changes in their ecology and thereby indicating an enhanced tactile sensing capability in some specialized species. Light perception is another highly refined and meticulously adapted sensory modality in lizards. Generally, lizards boast excellent vision, with the vast majority of species possessing highly developed color vision, often exhibiting capabilities that surpass those of humans. Their retinas are uniquely structured, containing multicolored oil droplets within their photoreceptors, and many species are further equipped with a fourth cone type that is specifically responsive to ultraviolet UV light. This remarkable adaptation allows them to perceive a significantly richer and much more colorful spectrum than humans are capable of seeing. This extended color perception, which crucially includes the UV range, is especially important for recognizing other individuals of their own species, accurately identifying suitable food items, and for transmitting complex communication signals. The harsh glare of the midday sun in open environments might necessitate specific adaptations for intense light conditions, such as the development of smaller, slit like pupils or specialized retinal structures observed in diurnal species. Conversely, nocturnal species frequently possess larger pupils and proportionally larger lenses to significantly improve their light gathering ability in low light conditions, albeit sometimes at the potential cost of overall visual acuity. Some lizards also uniquely possess a parietal eye, often referred to as a third eye, which is a distinct photosensory organ situated on their forehead. This organ transmits crucial information directly to the brain, influencing circadian rhythms and playing a vital role in thermoregulation, and it is even capable of distinguishing specific colors like blue and green to potentially help them ascertain the time of day. Chapter 3: The Ancient Pulse Within the Earth. Slowness. The entire existence of the lizard unfolds like a slow, deliberate poetry, an unhurried life that flows with an inherent grace. consciously resisting the incessant and often frantic demands of a hurried modern world. This intrinsic and pervasive slowness is profoundly and inextricably tied to their ectothermic nature, given that their metabolic rate is directly and intimately influenced by the prevailing external temperatures of their environment. When ambient temperatures are notably lower, their metabolic processes naturally decelerate, allowing them to conserve vital energy with remarkable efficiency. Many ectotherms, the lizard being a prime example, exhibit a remarkable capacity to adjust their metabolic rate on a seasonal basis, a physiological adaptation that is directly associated with variations in environmental temperatures. These metabolic changes are intricately linked to their activity levels and their fundamental energy requirements, showcasing a deep connection to their surroundings. This inherent metabolic flexibility grants them the extraordinary ability to endure prolonged periods of resource scarcity or environmental hardship by significantly reducing their overall energy expenditure. The Gila monster, for instance, epitomizes this profound patience. These creatures are widely described as being inherently sluggish and deliberate in their movements, yet paradoxically, they are capable of astonishing bursts of agility and speed when a critical moment genuinely calls for it. This observation is not a contradiction in their nature, but rather a natural and harmonious state of being. Their characteristic slowness represents the dominant and underlying rhythm of their life, an intentional act of conserving precious energy and simply existing with profound presence, while their swift, decisive action is a momentary, contained necessity, precisely employed when required. The lizard's characteristic stillness is in this sense a profound form of deep wisdom, offering a valuable lesson in not struggling against the world's currents, but rather moving fluidly and harmoniously with them, only exerting effort when it is genuinely and absolutely needed. It is a creature that quietly reassures us that there is no inherent need for urgency, that a gentle, deliberate, and measured procession through life is in fact the most natural and perhaps the most effective way to exist. The remarkably low metabolic rates characteristic of many lizard species mean that they require significantly less food intake compared to similarly sized endotherms, which must constantly fuel their internal heat production. This physiological advantage substantially contributes to their remarkable ability to sustain prolonged periods of inactivity and to conserve energy with exceptional efficiency. This adaptation, in turn, allows them to thrive and persist successfully in environments where food resources might be inherently scarce or unpredictably available, such as the harsh and demanding conditions of desert ecosystems. Their inherent slowness can also serve as a cryptic and highly advantageous survival strategy, enabling them to blend almost seamlessly into their surrounding environment, thereby significantly reducing the likelihood of detection by astute predators. For example, nocturnal lizards dwelling in cool temperate environments may exhibit notably higher metabolic rates at low temperatures compared to their diurnal counterparts. This specific adaptation partially offsets the thermal handicap associated with maintaining activity and functionality in cooler, less thermally forgiving conditions, allowing them to remain active when other ectotherms might be sluggish. However, this pervasive slowness should not be misinterpreted as a lack of responsiveness or capability. When environmental conditions are unequivocally optimal, such as when their internal body temperature is comfortably within their preferred and optimal range. Lizards are capable of exhibiting truly remarkable speed, agility, and precision, particularly when hunting prey or swiftly escaping immediate threats. The sudden explosive burst of speed demonstrated by a Gila monster, despite its generally sluggish and ponderous demeanor, serves as a powerful testament to this profound adaptive flexibility. This inherent ability to seamlessly switch between states of profound stillness and rapid, decisive action is an absolutely critical aspect of their multifaceted survival strategy, vividly demonstrating an intrinsic and deeply ingrained understanding of precisely when to conserve valuable energy and when to expend it with maximum effect. Their very existence offers a valuable and timeless lesson in ecological efficiency and profound mindfulness, an acutely conscious, unhurried, and deeply present engagement with the world, punctuated only by necessary, highly effective, and precisely timed actions. Chapter 4: The Ancient Pulse Within the Earth, Olfaction. This inherent slowness, which meticulously defines so much of the lizard's deliberate existence, extends gracefully and seamlessly into its other sensory modalities, offering a truly unique, deeply poetic, and highly sophisticated method for experiencing and interpreting its intricate, ever changing environment. Lizards employ their tongues in a remarkable and specialized fashion to smell their surroundings, a complex chemical analysis process that can be beautifully reframed not merely as a basic biological function, but rather as an exquisitely graceful and elegant conversation maintained perpetually with the very air itself, a continuous silent exchange of chemical information that flows through their world. This unique and highly specialized chemosensory mechanism involves a highly developed and distinctive anatomical organ known as the vomeronasal organ, or more commonly, Jacobson's organ, which is strategically located in the roof of their mouth, behind the internal nasal openings. This organ is a pair of blind-ended sacs lined with sensory epithelium, distinct from the main olfactory epithelium in the nose. When a lizard performs its characteristic and repetitive tongue flick, it meticulously collects microscopic, non-volatile chemical particles, both from the ambient air that surrounds it and from the substrate upon which it moves, whether that be soil, rock, or vegetation. The bifurcated or characteristically forked nature of many lizard tongues is a crucial and highly evolved adaptation that allows them to simultaneously pick up distinct scent molecules from two separate and distinct points in space, thereby providing a directional sense of smell, often referred to as stereoolfaction. This functions in a manner remarkably analogous to how stereoscopic vision provides depth perception to visual creatures, allowing for a more accurate triangulation of scent sources, pinpointing their origin with remarkable precision. This dual sampling allows the lizard to determine the direction of a scent trail or the location of a chemical signal, much like we use two ears to localize sound. Gila monsters, in particular, are renowned for their use of vigorous tongue flicking as a primary and highly effective method to meticulously locate the subtle scent trails of a potential mate during breeding season, or the elusive chemical signature of hidden prey, such as eggs buried in the ground, or small subterranean rodents. This specific action, repeated with deliberate rhythm and varying intensity, is a quiet, almost imperceptible tasting of the stillness, a sophisticated and intimate way for the creature to gather crucial unseen information from the chemical world around it, enabling it to comprehensively understand the intricate contours, subtle textures, and precise chemical composition of the atmosphere and ground in its immediate vicinity. Unlike mammals, which primarily utilize their nasal passages and their powerful sense of smell for olfactory perception, detecting airborne odors, lizards rely heavily on this unique and distinct tongue flicking mechanism and the vomeronasal organ to detect non volatile chemical cues that are present in their environment, molecules that are typically heavier and remain on surfaces or are carried in the air as micro droplets. These specific chemical cues can encompass a wide range of vital information, including pheromones, which are absolutely crucial for communication related to intricate mating rituals, species identification, and the vigorous defense of established territorial boundaries, as well as the distinct scent trails meticulously left behind by potential prey items, guiding the lizard to its next meal with uncanny accuracy. The frequency and the intensity with which a lizard flicks its tongue can vary significantly, depending directly on the specific type of information it is seeking, its level of arousal, and the perceived urgency of the particular situation. For instance, a Gila monster might noticeably increase its tongue flicking rate when it is actively and intently tracking a potential mate during the breeding season, following a pheromone trail, or when it is meticulously searching for food items that are cleverly buried beneath the ground, requiring a more focused and persistent chemosensory effort to pinpoint their exact location. This behavior is a cornerstone of their ecological success. This gentle, methodical, and almost meditative motion of the tongue guides the lizard with remarkable precision and unwavering certainty through its complex world, constantly gathering data from the chemical landscape. And by observing this fascinating behavior, it implicitly invites the human listener to discover a similar profound sense of peace by experiencing their own present moment with a heightened and deeply focused sense of awareness, engaging all their senses in a more deliberate manner. It represents a slow, deliberate, and highly refined form of chemosensory exploration, allowing the lizard to meticulously construct a detailed, dynamic, and comprehensive chemical map of its immediate surroundings. This map is not visual, but a tapestry of sense, a silent understanding of the environment's chemical makeup. Through this silent olfactory dance, this continuous sampling of the air and ground, the lizard remains intimately and continuously connected to its environment, constantly interpreting the myriad subtle chemical messages that are effortlessly carried on the wind and those that are subtly etched into the very landscape itself, providing an unbroken and vital stream of sensory data that informs its every move and decision. This intimate connection allows the lizard to navigate, forage, and interact socially in a way that is profoundly integrated with the chemical signals of its world. This silent symphony of scent is as crucial to its survival as sight is to many other animals, allowing it to perceive a dimension of reality often invisible to us, a testament to the diversity of life's sensory adaptations. The lizard's tongue, therefore, is not merely a means for tasting food, but a sophisticated instrument for perceiving the unseen, for reading the silent declarations of its environment and the creatures within it. It's a reminder of the subtle. Chapter 5: The Smallest of Waves, a Tiny Ascent, Head Nod Forms. At the very core of the lizard's deliberate, measured, and often slow existence lies the iconic head nod, a deceptively simple yet profoundly repetitive movement that serves a dual and essential purpose. It is both a fundamental and widely utilized form of communication within their species and a gentle, self contained, rhythmic expression of its very being, a visible pulse of its internal state and intentions. This seemingly modest action, often overlooked by the casual observer as an idiosyncratic twitch, is in reality an extraordinarily complex and highly ritualized display, particularly prominent and finely tuned in species such as the ubiquitous anoles. The precise meaning and subtle intent behind this specific movement are intricately determined by its nuanced quality, its contextual setting, and its precise execution. For instance, a timid wobble, a soft, light bob, or a lazy, gentle, almost languid nod all convey distinctly different messages and intentions than a sharp, sudden, or jerky motion, which might indicate aggression, alarm, or heightened territoriality. These subtle yet significant variations in the amplitude, the extent or height of the head's vertical displacement, frequency, how often the nods occur per unit of time, and duration, how long each individual nod or sequence of nods lasts, collectively encode a rich, diverse, and surprisingly complex array of information, allowing for sophisticated and nuanced communication within their silent visual world. These specific patterns are often species specific, forming a unique visual dialect that allows individuals to recognize their own kind and understand social cues. Lizard head nods, frequently referred to in scientific literature as head bobs, or more formally as display action patterns, DAPs, are typically employed across several critical and distinct contexts within their social and ecological lives. These vital functions include actively asserting dominance over potential rivals or subordinates within a hierarchical structure, vigorously defending established and crucial territories from intruders such as competing males, attracting potential mates during the intense breeding seasons through elaborate courtship rituals, and even serving as a subtle yet effective form of predator avoidance by conveying specific information, such as the lizard's awareness or intent, or attempting to blend into the background by minimizing conspicuous movement. The speed and the overall extent of the head nod are absolutely crucial determinants of its conveyed message and perceived intensity. For example, a high amplitude, rapid series of bobs might very clearly signal overt aggression or emphatically declare a strong non negotiable territorial claim, indicating a firm willingness to defend its space at all costs. Conversely, a slower, less pronounced, and more subdued nod could represent a more submissive posture, a gesture of appeasement to avoid conflict, or perhaps an exploratory movement used to cautiously gauge the intentions of another individual or assess a new environment without provoking a confrontation. Extensive research into the intricate display behaviors of anoles, a well studied group, has meticulously categorized these movements into specific display actions, which are defined as precise sequences of head nods and other coordinated body movements that are highly species specific and, crucially, carry precise and unambiguous messages, forming a distinct visual vocabulary that prevents misinterpretation. These day apps are often hardwired, genetically determined behaviors, The most calming and peaceful interpretations of this particular movement are observed in the slow, low amplitude bobs that appear to exist purely for their own sake, often performed when the lizard is relaxed, basking, and not under immediate intense social pressure or threat. This soft, almost imperceptible ascent and descent of the head can be perceived as a gentle, rhythmic, and rocking motion, a subtle, undulating wave that exquisitely mirrors the slow, meandering journey one might take toward a state of deep, profound, and utterly restful sleep, a kind of self soothing rhythm. Even when employed to convey messages of dominance or to assert territoriality, the head nod remains, remarkably, a highly stylized and energy efficient form of communication, artfully designed to often avoid the need for direct, potentially injurious, and metabolically expensive physical confrontation. It constitutes a sophisticated visual language, often complemented by other visual displays, such as the rapid extension of a vibrant dewlap, a brightly colored throat fan, or a controlled body compression to appear larger and more imposing, all of which together enable lizards to convey complex social information effectively from a distance. These elaborate visual signals allow for assessments of size, fitness, and motivation without physical contact. This intricate choreography of motion thus transforms a seemingly simple head movement into a profound and eloquent statement, making it an essential, expressive, and deeply embedded part of the lizard's rich silent narrative, a testament to its communicative ingenuity and its capacity for nuanced nonverbal expression. The head nod is a fundamental building block of their social world, a visual pulse of their presence. Chapter 6: The Smallest of Waves, a Tiny Ascent, Other Movements. The characteristic head nod, while central and highly significant, is but one component within a much larger, nuanced, and intricately woven silent language employed by lizards, a full lexicon of subtle gestures that collectively articulate their intentions and states of being. These fascinating creatures also engage in a variety of other slow, deliberate, and purposeful movements, each serving distinct and vital functions, ranging from intricate social communication to fulfilling fundamental physiological needs. Among these, some species are observed performing what are commonly referred to as push ups and arm waving displays. When viewed through a calming and meditative lens, these actions are not necessarily aggressive signals of overt dominance or passive submission in the human sense, laden with emotional baggage, but rather quiet, intrinsic acts of being, deeply connected to their physical presence and their interaction with their immediate environment, a conscious shaping of their body and space. The push up, a frequently observed and widely recognized display behavior in numerous lizard species, particularly in anoles and other territorial lizards, involves the rhythmic raising and lowering of the body by precisely extending and flexing the forelegs, often in a series of repetitions. Scientifically, these specific movements are often interpreted as crucial territorial displays, strategically utilized to clearly signal an individual's robust presence, convey its physical fitness and vigor to potential rivals, and emphatically assert its undeniable claim over a designated and valuable area, such as a prime basking spot or a foraging patch. From a more poetic and introspective perspective, this action can be beautifully reimagined as a gentle, deliberate stretch of ancient, resilient muscles, a simple yet profound act of finding comfort, stability, and proper form upon a sun warmed stone. It becomes a quiet affirmation of their rightful and peaceful place in the world, a subtle yet firm declaration of belonging and mastery over their small domain, a moment of physical self expression. Similarly, arm waving, a distinctive motion often interpreted by ethologists as a gesture of submission or appeasement, is frequently observed in species like bearded dragons, particularly in the presence of a larger, more dominant, or potentially aggressive male. This behavior can be beautifully perceived not just as an act of yielding to a rival, but rather as a soft, almost ethereal wave of surrender to the embracing warmth of the sun itself, a quiet and graceful ballet of acceptance and harmony with the greater forces of nature, a peaceful acknowledgement of the existing social order. This particular behavior, notably prominent in species like bearded dragons, serves as a clear signal of non aggression and unequivocally expresses a willingness to avoid potential conflict and confrontation. It effectively diffuses potential territorial disputes without the need for physically damaging combat or direct energy consuming physical engagement, thereby preserving valuable energy and avoiding potential injury, which could severely impact survival and reproduction. Importantly, these actions are far from random or arbitrary. They constitute an integral and highly specific part of a species specific repertoire of precisely regulated signals that are absolutely crucial for regulating complex social interactions and for maintaining clear hierarchies and social order within lizard communities. The precision, consistency, and repeatability of these ritualized displays allow for remarkably clear and unambiguous communication, thereby minimizing any potential ambiguity in their intricate silent language and ensuring social order and stability within their often dense populations, allowing for peaceful coexistence within established structures. Other movements, such as specific tail undulations or head pressing against the substrate, can also carry communicative weight, conveying information about readiness to mate or stress. Indeed, the lizard's entire behavioral choreography is strikingly quiet, almost entirely devoid of any sense of frantic urgency, and instead imbued with a profound and pervasive sense of peace, deliberate intent, and natural rhythm and intrinsic mindfulness. These movements are not merely random acts or unconscious reflexes, but rather a rich and expressive lexicon of a slow body's language, deeply rooted in its evolutionary history and ecological context, shaped by millennia of natural selection. Each individual gesture, from the quiet rhythmic bob of the head to the patient methodical flicking of the tongue, possesses a distinct and vital purpose that, when re examined through a more contemplative lens, can be reimagined as a calming, gentle, and utterly peaceful action, free from human imposed notions of stress or anxiety. This intentional reframing removes any inherent sense of aggression, intense competition, or underlying stress from these natural behaviors, instead presenting the lizard as a creature of remarkable grace, profound tranquility, and ecological efficiency, where every single motion is an integral and beautiful part of a larger, unhurried, and deeply meaningful choreography that speaks volumes without a sound. These nuanced and precisely executed movements eloquently demonstrate that effective communication in the natural world does not invariably necessitate loud sounds, aggressive vocalizations, or overtly aggressive displays. Sometimes the most profound and impactful messages are beautifully conveyed through the subtlest of gestures, forming a silent pact of harmonious existence and mutual understanding, a testament to the power of nonverbal communication. This quiet, deliberate communication allows lizards to manage their social lives with an elegance that belies their often solitary or seemingly simplistic existence, reflecting a deep connection to their environment and the rhythms of life. Chapter 7: The Quiet Declaration of Space. When a lizard engages in its characteristic head bobbing to assert its territorial boundaries, this action is far from an aggressive act of confrontation, as humans might initially interpret it. Instead, it represents a peaceful, fundamental, and deeply ingrained biological need to define and secure a quiet, personal space for rest, for efficient foraging, for seeking refuge from environmental extremes, and for overall security from predators and rivals. This particular gesture serves as a gentle whisper in the often loud natural world that subtly communicates, "This is my quiet place, my sanctuary, my chosen domain, where I can feel safe and thrive." Many lizard species exhibit strong innate territorial behaviors, which are essential for resource allocation and species survival. These ritualized displays, which can encompass not only specific patterns of head nods, but also distinctive push ups, lateral body compression to appear larger, and even species specific dynamic color changes, are absolutely crucial for minimizing the occurrence of costly, energy intensive, and potentially injurious physical conflicts. These highly ritualized and elaborate behavioral patterns allow individual lizards to accurately assess each other's physical fitness, vigor, and overall willingness to actively defend a given territory, all without the need to engage in direct, physically damaging, and metabolically expensive fights. This sophisticated system of signaling effectively saves valuable energy, reduces the inherent risk of injury for all parties involved, and maintains a level of social order and predictable interaction within the lizard community, promoting stability. The anole, a true master of this intricate silent language, possesses the extraordinary physiological ability to dynamically change its skin color to communicate complex messages with its immediate surroundings and other individuals. This remarkable physiological adaptation is a graceful, fluid, and highly adaptive extension of its territorial declaration, adding another, often more immediate dimension to its silent pronouncements. Its skin effectively transforms into a living, responsive canvas that flawlessly mirrors the subtle shifts from vibrant green to earthy brown, depending on its environment, emotional state, and the specific message it intends to convey. This is a quiet and visually eloquent way of affirming its deep belonging and implicitly stating, "I am an integral part of this specific place, this ecosystem. I blend with it, and I claim it as my own." This physiological color change serves not only as a primary and highly effective mechanism for camouflage against varying backgrounds, allowing it to disappear from view and evade predators, but can also powerfully signal dominance, submission, or even a state of stress or excitement to other animals within its social sphere. For example, a dominant male animal might darken its body color significantly when asserting its authority or engaging in a territorial challenge, making itself more conspicuous and visually imposing, a clear signal of strength. Conversely, a submissive individual might lighten its coloration when retreating or acknowledging defeat, making its intentions unequivocally clear to its conspecifics and actively avoiding further conflict. This inherent ability to dynamically alter its appearance effectively removes any lingering sense of overt aggression or stressful confrontation from the concept of territoriality, and instead presents it as a serene and natural act of a creature gracefully finding and maintaining its peaceful corner within the vast and interconnected world, a declaration of presence without overt violence. Territoriality in lizards is frequently centered around the crucial access to essential and often limited resources, which typically include optimal basking sites that provide vital heat for thermoregulation, reliable food sources to sustain their metabolism, safe nesting sites for reproduction, and secure refugia from predators and extreme weather. By meticulously establishing and diligently defending a territory through an elaborate system of visual and behavioral displays, rather than resorting to direct physical combat, lizards are able to conserve valuable energy reserves and significantly reduce the inherent risk of injury, which could severely impact their survival, ability to forage, and reproductive success. These displays are almost invariably performed towards intruders of the same species or very closely related species, who represent direct competitors for resources and can involve a strategic increase in apparent body size through puffing up their bodies, erecting crests or spines, and exaggerated posturing, often in conjunction with the display of bright contrasting colors on their dewlaps or bodies. The clarity, consistency, and predictability of these intricate signals are absolutely vital for maintaining social order and stability within a lizard community, thereby ensuring that each individual can effectively find, establish, and maintain its designated space with minimal disruption and conflict, contributing to the overall ecological balance and reducing unnecessary aggression. The concept of resource holding potential, RHP, in behavioral ecology explains how these displays allow individuals to assess each other's fighting ability without actual combat, thus maintaining stable social structures. This quiet declaration of space, therefore, is not a selfish act, but a fundamental ecological strategy for species survival and efficient resource partitioning. Chapter 8: A Quiet Dance of Color and Light. The subtle head nod, beyond its crucial role in territorial claims and displays of dominance, is also an indispensable and beautifully integrated part of a beautiful, entirely wordless courtship ritual, a silent and intricate dance between potential mates that communicates attraction, intent, and species recognition. The green anole, for instance, famously utilizes a striking and vividly colored dewlap, a brightly hued extendable throat fan located beneath its chin, as a primary visual signal to attract the attention and interest of a potential mate. This remarkable dewlap, with its often intricate patterns and vibrant species specific colors, is far more than a mere signaling device. It is, in effect, a folded work of living art, a momentary flash of exquisite beauty that bursts forth with startling intensity within their otherwise tranquil and often camouflaged world, a true visual spectacle designed to capture the eye. A poetic description might capture this display as a blush of the morning sun or a mosaic of earth tones, transforming it into a silent visual whisper of admiration and an open invitation to approach, a signal of vitality and genetic fitness. During the elaborate courtship displays, the dewlap is rapidly and rhythmically extended and retracted, often in precise conjunction with specific head nods, meticulously orchestrated to capture the attention and generate interest from discerning potential mates from a distance. The specific color, pattern, and size of the dewlap are frequently species specific, serving as a clear identifier of species and even population, and its intensity and vigor can fluctuate significantly depending on the male's overall health, his current nutritional status, prevailing hormonal levels, and even his environmental temperature, thereby acting as an honest and reliable signal of his genetic quality, vigor, and fitness to a scrutinizing female. This honesty is critical, as females invest heavily in reproduction. In this quiet and elegant dance of courtship, the head nod becomes a truly shared and reciprocal gesture, a communicative movement that underscores mutual interest and acknowledges the other's presence and potential receptiveness. The male's initial bob, often bold and pronounced, signifying his intent and vigor, is frequently met with a gentle, acknowledging bob from the female in response, indicating her receptiveness or interest, a subtle acceptance of the invitation to engage. This interaction is not a loud declaration of intent, but rather a silent conversation, a gentle call and response that beautifully echoes a shared inherent rhythm, indicating a willingness to engage further in the courtship sequence. Female lizards typically carefully evaluate the male's display, including the vigor, consistency, and precision of his head nods, the impressiveness of his dewlap extensions, and his overall body condition as critical cues in their mate selection process, choosing the most suitable partner to ensure the success of their offspring. This shared moment of non competitive, peaceful exchange of motion is profoundly calming and reassuring, emphasizing mutual acknowledgement, interest, and the harmonious development of a potential reproductive bond. The inherent complexity and highly ritualized nature of these courtship displays ensure that mates are selected based on clear, reliable signals of fitness, genetic quality, and accurate species recognition, ultimately contributing significantly to reproductive success and the perpetuation of the species, ensuring the continuation of their genetic lineage and adaptation to their environment. These displays are also crucial in preventing costly interspecies hybridization by ensuring only members of the correct species recognize the signals. Beyond the prominent head nod and the vibrant dewlap display, other subtle yet crucial visual cues, such as specific body coloration, which can include intricate UV patterns that are entirely invisible to human eyes, play a significant and often underestimated role in attracting suitable mates and conveying complex social information. Many lizard species possess the remarkable capability of UV vision, allowing them to perceive an additional spectrum of colors and patterns that are absolutely crucial in processes like species recognition and the critical selection of mates, giving them a richer visual world that is hidden from human perception. This hidden spectrum adds another profound layer of silent visual communication to their courtship rituals, making their world of color and light far richer, more complex, and infinitely more intricate than what human eyes are capable of perceiving. For example, a male might display UV reflective patches that indicate his health or genetic quality only visible to a female with UV vision. The entire courtship ritual, encompassing everything from the initial impressive visual display by the male to the subtle shared nods of acknowledgement, the intricate patterns of UV light, and often specific pheromonal cues, unfolds as a subtle, intricate, and deeply meaningful ballet, a testament to the powerful effectiveness and profound beauty of nonverbal communication in the diverse and wondrous animal kingdom, a silent declaration of life and love, orchestrated by light, color, and ancient instincts. This complex interplay ensures successful reproduction in a world where every action has an energy cost and a potential consequence. Chapter 9: The Unseen Compass and the Mind's Eye and Rhythm of Return. The lizard's intricate perception of its world is a subtle and truly wondrous amalgamation of its highly specialized visual capabilities and its characteristically quiet, deliberate, and often measured movements. Its camera eye, a marvel of biological engineering, efficiently refracts incoming light to meticulously form a sharp image on the retina, functioning with a quiet grace and remarkable precision. Lizards generally possess excellent visual acuity, enabling them to discern fine details in their environment, from the intricate patterns on a leaf to the subtle twitch of a distant insect, and frequently exhibit keen motion detection, both of which are absolutely crucial for successfully hunting elusive prey and for effectively avoiding ever present predators that might lurk in the shadows or soar above. The head nod in this specific context transcends its direct communicative role and becomes a gentle yet powerful tool for enhanced perception, serving as a quiet and methodical way of surveying its complex world and deeply understanding its precise place within it. This deliberate movement significantly aids in depth perception through a phenomenon known as motion parallax, where the relative movement of objects at different distances helps the lizard accurately gauge depth and spatial relationships as it moves its head from side to side, creating a dynamic 3D map of its surroundings. The lizard's slow, deliberate, side to side head movement can be visually interpreted as it meticulously takes a series of mental photographs, actively using motion parallax to precisely perceive depth and to subtly feel its way through its three-dimensional space, a strategy especially important in heterogeneous and visually complex environments where precise depth judgment is critical for navigation, accurate striking at prey, and safe locomotion across uneven surfaces. This constant visual sampling ensures a continuous update of its spatial understanding. This profound embodied wisdom extends deeply into the lizard's fundamental survival instincts and highly developed predator avoidance strategies, which are honed by millennia of evolutionary pressure. When a potential predator is sensed to be near, perhaps a hawk overhead or a snake slithering nearby, a lizard may instinctively scale back its more conspicuous head-bobbing displays. A normally hearty nod, used for communication, might subtly transform into a timid wobble or cease altogether, becoming perfectly still and blending into its environment. This alteration is not merely a sign of fear in a human sense, but rather a quiet, intelligent, and highly adaptive act of self-preservation, a calculated and effective response to a perceived threat that prioritizes survival. It represents the lizard's innate wisdom to intuitively know precisely when to remain perfectly still and inconspicuous, blending seamlessly into its background, a silent acknowledgement of the inherent dangers of the world and a graceful, deliberate decision to simply exist, unseen and at peace within its surroundings, hoping to avoid detection. Predator avoidance strategies in lizards are remarkably diverse and sophisticated, encompassing a wide range of tactics, including highly effective camouflage, cryptic coloration and patterns, complete immobility, freezing, rapid flight to the nearest cover, defensive displays, e.g., bluffing, puffing up, hissing, and in some cases, tail autotomy, self amputation of the tail, to distract a predator while the lizard escapes. Reducing conspicuous movements, such as head nods, significantly helps them blend seamlessly into the background, making them far less detectable to visual predators that often rely on movement to spot their prey. The extraordinary ability to freeze or minimize any discernible movement is a highly effective anti predator tactic, allowing the lizard to become, in essence, one with the landscape, disappearing into its environment and maximizing its chances of survival against sharp eyed hunters. As the day gradually comes to a gentle close, mirroring the rhythmic pulse of the earth, the lizard's movements naturally begin to slow, following an inherent, unhurried rhythm of its existence, guided by the setting sun and dropping ambient temperatures. This transition from activity to rest is not abrupt, but a gradual, deliberate winding down. Gila monsters, for example, exhibit an extreme form of this behavior, spending up to an astonishing 98% of their lives hidden away in the safety and thermal stability of burrows or sheltered rock cavities, conserving energy and avoiding harsh conditions, both heat and cold. They emerge primarily during the cooler mornings and evenings, meticulously avoiding the intense energy sapping heat of the midday sun, a prime example of their precise behavioral thermoregulation. This retreat is not born of fear in a human sense, but rather represents a fundamental biological need for a safe personal sanctuary, a place of secure retreat from both environmental extremes and potential dangers. The burrow serves as a quiet home, a profound place of rest, recuperation, and retreat, consistently providing stable temperatures and invaluable protection from both environmental harshness, like extreme heat, cold, or drought, and predatory threats. Many diverse lizard species utilize burrows, natural rock crevices, or dense vegetation as critical refugia, especially during periods of extreme temperatures or throughout the duration of the night when they are most vulnerable or metabolically inactive, entering a state of torpor. The narrative can beautifully describe this slow, gentle retreat, a deliberate movement away from the bustling activity and demands of the day and towards the deep restorative darkness and coolness of the earth. It is a movement of profound contentment, a seeking of comfort and security. As the lizard meticulously settles into the comforting confines of its sanctuary, its characteristic head nod, which throughout the day served as a vital form of communication and perception, subtly transforms into a final, drowsy, almost unconscious motion of a body settling into a deep state of rest. It is a slow, profoundly tired nod, a final, tender gesture of peace and contentment before succumbing to the deep, restorative embrace of sleep, a truly serene ending to its daily cycle. This daily cycle of activity and subsequent retreat is intrinsically governed by their deeply ingrained biological rhythms and the ever present thermal demands of their surrounding environment, a perfect natural clock dictating their every active and restful moment. The lizard in this final act is finding its quiet, personal place of peace and security, a fundamental need echoed across all living beings, just as the human listener is implicitly encouraged to find theirs, culminating in a final and gentle transition into stillness, embodying the profound and timeless harmony between creature and the vast, intricate cosmos, a perfect end to a day lived in deliberate, mindful harmony with the planet's ancient pulse.